Okay, I just want to revisit this problem real quick, because notice that when I did this problem, I had this 1/3 here. And I typically don't leave the 1/3 there, so I just want to revisit it without the 1/3 and see if we get the same result. So my original series is 1/3n squared minus 4n plus 5 and equals 1 to infinity. Again, the 3n squared is going to overpower the 4n and the 5, and the theory is that 1/3, I could put that in front and 1/n squared, and usually what I do is I just ignore any sort of constant coefficients and just look at 1/n squared. So I'm really not going to look at this. I'm really going to consider 1/n squared, n equals 1 to infinity, which this is a p series convergent with p equal to 2, which is greater than 1. So if I set this limit up, I'm going to do a little faster this time. 3n squared minus 4n plus 5, 1/n squared. Notice in this case, this time here, I had the 3n squared, the n squared term up top, and then the original series down in the denominator. I flip-flopped it for this problem here. It doesn't really matter. So I'm going to flip and multiply, so I get the limit as n goes to infinity of n squared over 3n squared plus 4n plus 5. I multiply top and bottom by 1/n squared. I get the limit as n approaches infinity of 1/3 minus 4/n plus 5/n squared. These guys both go to 0. I get 1/3. Well, in this scenario, I got 1, and in this scenario, I got 1/3. Oh, where'd that 1/3 come from? It came from this guy over here. Regardless, as long as the limit of these two series is finite, meaning not infinity, and it's not 0, we can say that it converges by the limit comparison test. So we write limit comparison test. You don't really need to rewrite this, but I like to put it all in one spot. P series convergent. P is equal to 2 less than 1. Just makes it easier that, oh look, makes it easier for the grader. Oh, let's just all look at this is the test, all the tests that you used. So notice that you need to write down what is the reason for the convergence of the original series, excuse me, not the original series, but the comparison series that I'm using, which in this case is a p series of 1/n squared. I use a limit comparison test. That means I'm going to look for a limit over here. I did not get 0 or 1, so therefore I know that the series converges or diverges. And since this guy converges, that means this guy converges as well. So the conclusion of this series is the same conclusion of this series, provided that you don't get 0 or 1. Excuse me, 0 or infinity.